We have a demo on Mark 2. So this is a composite printer. So yesterday also Ravi Haramani sir was talking about composite printers. And even today also Soma sir gave a small introduction what a composite printer is, and most probably he has shown this picture in the session that we have this printer and we are going to do a demo on this. So we'll begin from basics, a little from basics, and then we'll transfer ourselves to this. So what actually a composite is? So yesterday, some people were there in the participants and who were trying to print some composite materials. So composite PLA itself, it was infused with carbon fiber and tried to print out a kind of cube, and it came out somewhat like this. So from a cube is required, and we are getting this kind of parts. It means you understand that there is a little bit difficulty in thinking that carbon fiber. Even though carbon fiber is already infused into the PLA filament. So that is one of the easiest methods, and still there is some issue. So what actually is in composite material? Composite material. Can anybody give a small? What actually is a composite material? Mixture of two or more different materials. Okay. So it is basically put together. Okay, I understand. So it has been taken, composite material has been taken from the Latin word compositus. So com means together and ponere means to place. So two materials have been placed together as the basic understanding of composite. So we'll come to the mixture also, the word which you have used. So alloys nothing but solutions. So alloys are solutions of metals together, which is homogeneous in nature. That is also a kind of two materials can be infused together, which is together. Then comes a compound. Compound is if the two materials are reacting with each other chemically, then that becomes a totally new material, that is basically called as compound. Then comes composite. So combination of two or more materials, and they should be physically distinct. So it shows that one is yellow in color, one is matrix as well as the reinforcement together. So we get that as a composite. So that is, we cannot call it as a mixture. It is a subset of mixture, but it has to be engineered in a way. Why do we use composite materials? There are various applications, just like in aerospace. So last time when I was in HAL, and so before you see the nose cone here. So this is the nose cone. So this nose cone before they used to make out of aluminium 2024, and that is so huge that it was made in form of panels. It was higher than, I should say, 3-story building. So we used to assemble this whole nose cone, and this whole building, this whole thing used to go around more than 10-story building. This is GSLV Mark 3. Later on, while I was there for 1 year, within that time period itself, it was proposed that why can't we go for a CFRP? And now half of them are made with aluminium 2024 and half of them are made with CFRP, carbon fiber reinforced plastics. So the whole thing, before it was in form of panels, different panels were riveted together, but now it is a single whole body with just one CFRP. So huge time goes into making those composite materials, and basically that is done with the help of this hand layer method itself. And that is, I should say, twice safer compared to using the panels and riveting them together. Because there were lakhs of rivets at once. So if any one of those fails, we have the risk of the failure of the whole launch itself. Similarly, there are applications in automobiles like the fenders we have, in marine, electrical, biomedical, construction, everywhere there are applications. That's why we are actually looking to go into composites. So yes, this is PS aircraft, what we have, HALPS, Hindustan Aeronautics Limited. So most of these parts are made in National Aerospace Laboratories. It is a CSIR laboratory in Bangalore. So they are making this carbon fiber parts. So back in, I think so in 2019 I saw. So since then they have started making the CFRP. Only the main parts they make, around I should say 40% of the parts of this HALPS, the outer structure is made out of that, but still they were not able to make the wings because there is a huge load on the wings of the aircraft. For example, this Airbus 350, it already has around 53% of carbon fiber is being used, so composite material is being used. So we can see that yes, there is a huge scope of composite materials. It's also used in musical instruments. So I have got mine here. Okay. I don't know much how to play better, but yes, you see. So this is the composite material. Different strips of this wood have been placed on another strips of this wood, and that is basically used to mold here. So this is in this mold they do using pressing, and they get the final shape here. So this is also an example that yes, we have applications of carbon fibers in almost all of the day-to-day lives. We can say even our clothes are a kind of composite materials, our shoes are there, our slippers, almost all of these things. Even this, not truly, but in some way we can say this is a composite material. Then the question comes, because there are applications in every field, how do we actually manufacture it? There are many methods. I just go through all of them, just minute by minute. First one is hand layup method, where we place the fibers, we place the gel coat. If I want to place it here, I insert the release coat here so that the fiber comes out easily, the composite comes out easily. On that, I place my this thing, the fibers, and then the matrix in the form of resin is placed. And then with the help of the roller, you can see a person, he is making a huge component just out of this hand layer method. Here the biggest advantage is that you can make components as big as feasible, as big as you want. So there is no restrictions on the size of it, just you have to make sure that your mold is as big as you require. So nowadays even boards are available, which the whole board itself is made out of composite fibers. Composite material. Then second one is vacuum bagging, where the pre-peg, which is already with the resin basically the composite as well as the fiber cloth is placed there, and we apply vacuum. We try to get out the air from it. So some of the extra air which is still trapped inside, that comes off, as well as the resin which is inside, that also extra resin also come off. And finally there is huge pressing, and the final part will be in this shape. Vacuum. And then filament winding. Nowadays hydrogen cylinders is of it is being highly manufactured using this filament winding. So it will keep on rolling, and the filaments will be winding on the surface of it. So this is one, since this is rolling, only it's possible to make some cylindrical components or closer to cylindrical components. Then comes pultrusion, just like some of our interns had shown yesterday. The filament extruder is there. So the same method is being used here, but different filaments will be included together, and the final component will be infused with the resins, and we'll get the final composite material in the form of threads or something. Then spray method, it is similar to the layup method, but the fibers are in the form of small chopped fibers, and they will be sprayed with the help of sprayed on the mold itself, and on that we place the roller with the, and also the resin. So finally we get, again here we don't have the limitation of the size. Sheet molding, this is almost similar to the sheet lamination. So different sheets we have. This is also similar to the I forgot the name, vacuum bagging. Only difference is that we do not place any kind of vacuum here, we just press it with the help of the rollers. Then bulk molding, we have some fibers with us, resin as well as the fiber together. We have a kind of bulk, we have a kind of mixture, and then we place it in a bulk, this mold, and then press it, and we get the final component. Resin transfer, this is basically almost used for injection molding. So the injection molding process is also used for already the fibers will be placed here, fibers will be placed there, and then resin is poured inside it, and extra air will be vented out. So these are few of the manufacturing methods, basic manufacturing methods. But there, we did not see additive manufacturing, since we are in this additive manufacturing laboratory. But nowadays, these composite materials are not widely used for. So this additive manufacturing is not widely used in the composite. Reason, because it is very complicated. So these mark forged people, they have come up with an idea that we can print a composite out of it. There are various methods of printing actually. You can print with using dual extruders on the FDM itself. Two filaments will come and simultaneously, or else sequentially you can place your parts, then you can print it. But that is not truly a composite material. Reason behind that, there must be a fiber and there must be a matrix, which is not available there. So this is, we can say, a true composite printer, Mark-Forged Mark II. So these are few of the properties. So it used fused filament fabrication just like FDM, and also there is a continuous filament fabrication. So filaments can be in the form of flakes or small chopped fibers, or it can be in the form of small particles also. But here we are using a continuous fabrication filament. Build volume is 320 into 132 into 154 mm. And the materials which we are using. So the materials can be onyx, nylon, PLA. They have their own. All these materials are their proprietary materials, and onyx is one of their own developed material, which it's very much better than compared to the ABS also. Fibers, we have carbon fibers, fiberglass, aramid fibers, high strength, high temperature fiberglass, also normal fiberglass. So this can be used here. This kind of fibers as well as the plastic. Plastic basically means the matrix material. It can be used. Minimum layer height, it can be 100 microns, and maximum it can be 250. So I think so in FDM they might have informed you what is the maximum minimum layer height of this FDM.
0.12 millimeters.
Sir?
0.125 millimeters.
0.125. That basically it is 1.5, and some of the printers having the capability of 1.25 also. So this is having higher precision compared to the FDM printers. They have their own slicing software, that is Eiger Cloud, and you slice it on their software. So how I will begin? They have two nozzles. This nozzle is for the fiber, and this nozzle is for the matrix or the plastic areas. So these are few of the components which they have given to us. This is called as a sim. I will be showing you how this can be used for calibrating the nozzle. These are some of the fibers they have given, HSST, fiberglass, and other things. So how this demo is going to be, so first of all I will design a model, I will slice it, I will do the printer setup and give a print on this machine. Okay, so we will begin. So as I said, the slicing software is online, so I have to go to Google and I might have to search Eiger. It is also available on desktop application also, but still they charge around 1.5 lakh extra for the desktop application. So since this is a proprietary machine of their own, for every single thing they charge us, and we cannot even use a normal standard filaments here. So this will be the basic dashboard when you log in. I have already logged in, so this will show me 0 printers ready. So why my printer is not ready yet? Okay, let me see. It says configuration in process, and printer's name is there, MME Lab Mark-Forged Mark II. It is in process. So I have intentionally put in configuration mode so that when we configure it properly, we'll get the option of going ahead with the print. Here we can see the library. So whatever parts I have printed before, it will be shown here. I can make the files over here. So I have already uploaded a file. Then devices. How many printers have I connected to this account? So currently I have only one. Print jobs, have I done any before? Yes, I have several parts printed, and most of them were failed and cancelled, and some of them have been successful. This warehouse is nothing but the marketing strategy so that we can procure some things from them. Okay. So we'll go to the library, we'll import a file. I'll import, I can put my STL file here, or I can click here and I can browse it. So whichever file I want. So I have already uploaded here. I'll go to my folder. So this is standard part which I am trying to show you. So STL file, remember STL file can be used here. Sometimes they also allow the step files, but I have not used it, so I cannot confirm it. So this is the working area. It shows here the dimension of the part, how much time will it take to print, what is the final mass of the part, and then plastic volume, fiber volume, how much will it cost in US dollars, it shows here. If you want to make another part out of it, I can click on copy part and I can get it. Now the question is, how do I see where the fiber is? I click on X-ray. Oh, okay, before that, I'll select the material, which material I'm trying to print. So I have selected onyx. The reason behind that, because on the machine I have loaded onyx, so I am selecting onyx. Then I have carbon fiber again. You can use other fibers also, but since I have loaded there, I use carbon fiber. I'll select my printer, Onyx Mark II. There are several other printers of Mark IV, but since we have this, then I'll go to the X-ray. So this is where we are doing the engineering, what I said as a composite material. So blue color, what you see, this is the carbon fiber placing, and from here till here, it is a number of layers. So we can see it has 160 layers, and wherever we want, we can place our carbon fiber, and in which configuration we want, we can do it. So we'll add some of them. So let me before delete all of this. So this is automatically added. I'll delete it. I have deleted. Now this is my plastic. There is no fiber here. I have to add my fiber here. So there are some restrictions. So from the side wall, and from the bottom as well as from the top, there must be a difference of at least 2 layers of the plastic or the matrix. Now after that itself, only we can place the matrix, this fiber material. So let me start from the fourth to fifth. So we have 2 layers of carbon fiber I'm going to add. How will I add? I'll click on create new override. If I click on create new override, it asks me add fiber, remove supports, add supports. So since there is no support required here, I'll just click on add a fiber. If I click on add fiber, the fiber is already added here, and I can see it is on the 4th and 5th layer. It can be isotropic or you can make it concentric. I prefer most of the time concentric. And it shows it is only 2 layers. If I want to increase the number of layers, I click here, or else I can directly enter here and then click on apply. So the number of fibers will increase here. So still there are some limitations up to which, because if I click 100 here, 100 number of elements cannot be positive. For example, I'll show. But still, it accepts the number. This is the disadvantage, that it accepts the number, but it will not print here. So we have to trial and error and see what is the maximum number of layers we can apply for the fibers. We click on apply, and we have 4. Okay, concentric basically means if I want to print this. So if the fiber is aligned along the concentric means along the wall or along the periphery of this object, then it is called as concentric. So we'll go like this. If it is concentric, so that is a very basic thing we know, also understand this FDM printing, this slicing software what we have. So concentric means it will go like this. Isotropic means it will have some, yes, zigzags in there, it will be honeycomb or something else.
So as you said, if it won't be 100 printing also won't print it, or it wouldn't accept print.
Still it will accept, the number it will accept. I can keep it here, but it won't print.
Okay.
Whatever is visible here, only that will be print.
Okay, so 100 layers won't.
100 layers won't come, because there is no space for it. The four layer itself is this much. If I even multiply it, it will be maximum, I think so 10 layers here, not even 10 layers. Total it will be 10 layers.
Okay.
So, but still there is some disadvantage, I should say, bug in the software, that it accepts the number. Actually, it should not accept the number. So that sometimes may create a confusion when you are trying to add number of parts here, number of fiber layers here. So somewhere here also I will try to add from, you can add number. But I prefer that whenever you're making a composite, have some layers of fiber there and then again layers of this matrix there again, because if you have only the fiber, there is no bonding. So the synergy between the the fiber as well as the matrix is not happening. So again, I will pull it back to 4. I will apply the changes. Somewhere else also I will try to add. 9 to 11. I will click on create override. I add the fiber. Again.
Rituraj, one question. Can you do the reinforcement in the vertical section?
Reinforcement, since this is an FDM model, it's not possible that we can have the reinforcement in the vertical. Only at a one time, only one layer will be deposited. It's possible. But in case if you need that fiber has to be aligned in the vertical manner, you have to do align your object like this, so that it becomes like this. So this is one of the disadvantages of additive manufacturing of composite fiber, specifically in this machine, that if you have any curved path, just like a glass or something, so
Yes.
it will not be possible to have it along the walls. Even if you place it like this, only some of the layers will have, and then it will not be continuous along. So still additive manufacturing of composite is still in progress and people are trying to it. But the same thing can be done with a very less amount with the layer level. So I'll add one more fiber here. So I can add on the top also. Even I can add here. But still, if your matrix is here on the top of that, if I add a fiber, the fiber will peel off very easily. So still, they have to make sure that we cannot add here, but still we can add it here. So this is also one of the drawbacks which is available in there. So I can still add it here. You can see this is added. So, but we have to make sure that we do not add it here. I click on here. Similarly, I can place anywhere I want. How many number of fibers I want, I can add. Since I have added them, let us go for a print. Again, these people are very money-minded people. See the simulation, they are telling purchase an advanced plan to enable simulation. So again, they will take 1.5 lakh for simulation. And then again for scanning, they will take another 1.5 lakh for scanning. So yeah, this is how the business works. So since our part is ready, we have done some engineering, we should say adding the fibers in the material. We now shift to the printer, how to make the printer. So since the screen is very small, I have done a setup so that we can see the screen here. Okay. So I'll explain there also, and you can see the screen because the buttons are very small, everybody cannot see it. So I'll begin from there. Some of you can come on this side also if you wish. I'll click on cancel.
What is the material of the substrate?
This substrate. This is actually a ceramic bed. So this ceramic bed is 3-point mount ceramic bed. So we no need to screw it and just place it. The easiest part is that we can just remove it off, clean it with water, and then we can place it back. So I'll start from beginning. So this is how the home screen will be there, and we can do the connectivity. I can see that it is connected to our laboratory Wi-Fi. So only then it will show the connection. Otherwise, we can go and configure. So I don't want to do any kind of configuration because this takes some time for connection on Wi-Fi. So first thing is that I have to mount the bed. I have mounted. Then I'll go for bed leveling. I'll click on bed level. Shim. So many of you from industry or from academia might be knowing what shim is. So can anybody tell me what a shim is? This is a tool. Yes. So these seams are basically used to find the clearance between any two parts. So we cannot go ahead and everywhere use the verniers, or else if there is a small gaps, we cannot put the vernier there, and we cannot put the gauges there. So in that case, these are already well defined, and just we put in those places, and we can just see if there is a small resistance. We say okay, the thickness of that measured part is so much. So that is basically called as shim. So here it is mentioned fibers, plastic seam and fiber seam. So the best or else the advantage in this machine is that we know, even if you do not know anything, this system itself will give you all the information how to proceed. So it says shim bed level. I click on shim bed level and I just follow the instructions whatever it says. It is preparing the bed. The nozzle is heating to 27. Fiber nozzle is also heating to 27. Now it is telling, during this process do not rest your hand or put any pressure on the print bed, neither here nor on this machine. Next I'll click. To level your print bed you will need the two brass adjustment shims, and please press next if you are done with each of the steps. I click. Loosen the thumb screw until the print bed is at its lowest position. I have already done. So this is a thumb screw, 3 thumb screws are there. I loosen them so that the bed is at its minimum position. Then I'll click next. It is moving to the right position. It has moved. Now it is telling place the plastic shim between the print bed and the plastic nozzles. As I showed you before, there are two nozzles. The front one is the fiber nozzle, the second one is the matrix or the plastic nozzle. So I'll have to place it between the plastic nozzle and my bed. I have placed it and see that I place it there, and then I click next. Adjust the thumb screw directly, okay? So I'll have to adjust it so that there is a small friction. It is not going so easily, plus it is not coming off very easily. So there must be a small friction compared to the normal area. There must be a small friction. Just one of you can just move and see. There must be a small friction. That is how the shims are supposed to be used. You see, there is a small resistance is there. So when there is a small resistance, we have to just stop. I can click on next. It is moving to the right position, left position, sorry. Again, the same thing we'll do here also. I'll put it between the nozzle and I'll screw it. And I'll continuously move it so that I get the exact clearance. Yeah, one of you can just move and see if you're getting some resistance. There is some resistance, right? So that is the resistance we should have. It should not be very tight, neither it should be very loose. Then I click on next. Moving to the back position, that is the front, that is the back. Again, it says the same thing I have to do there also. So for making a plane, how many points are required? 3 points are required. So if I adjust in 3 places, definitely my whole plane will be adjusted. The whole bed will be adjusted. I feel that this is a little bit tight. I loosen it. It must be just resistance. This is required because when the deposition is happening, it must not deposit in the air, neither the nozzle must go and strike on the bed. So now we know that there is a proper clearance between the bed as well as the nozzles, and the bed is also aligned. I'll click on next. It's moving back to the right position. Oh, this one is again telling me to do the same thing. So can anybody tell me why it is telling me to do again?
Might be gap is less.
Yeah, because since I have adjusted here, so there might be chance while adjusting here that might have gone down or something might have happened. So this is the second. Slide the fiber seam between the print bed and the fiber nozzle. Now it is telling me to slide the fiber seam. So I leave the plastic seam and I have to make sure that I am taking the fiber seam. Plastic bed as well as this. the bed as well as this fiber nozzle. Still, there is a resistance. Click on next. Adjust the exposed 2 mm Allen key. So there is a Allen key is there here. So since I have it proper, I don't need to adjust. Same resistance is there. So now since the bed is adjusted, on that I have also adjusted the fiber nozzle as well as the plastic nozzle. And now I can do a test print. So I'll click on test print. It is always advised to do the test prints. So they have their own files which can be used for test prints. Or else if you have a part which can cover the whole area of the bed, that also you can print. So you can see here there is something called as, okay, still it is heating. There will be something called as purging also. Let us see if that comes or not. So it heats. So since this bed is ceramic and there is no heating here, so bed temperature is not required. So only the heating of the nozzle, fiber nozzle as well as the plastic nozzle is required. So now it is heating to 76, 79, okay. You will see at what temperature it goes finally to. It is inbuilt. The only, I should say this is a kind of white elephant. We cannot do much research on it. Because if you want to change something, it is very hard to do, or else they have locked almost everything. Just use their material and do the printing. Only you can play with the designs as well as placing of the fibers. Nothing. Actually we have tried, since this was in warranty, we thought why not test our own parts. So several times the nozzle got clogged and we used the warranty for that.
The fiber you're placing will also get heated?
Yes, it gets heated. So this carbon fibers, I'll bring one carbon fiber. So this is the carbon fiber. So these carbon fibers basically they are also heated to high temperature. I think it is 330 degrees Celsius. So on heating it becomes a little bit soft. So it is actually infusing with the plastic material when it is heated. And it is also easier to cut. Plastic is melting, but this is not melting. Yes, it is directly inserted. That's why I have placed the layers below only. So after a few layers, we'll be able to see fiber placement also. There are fibers of fiberglass. Kevlar is there. HSST, high temperature thing is there. You hear the noise, right? So the noise is nothing but the motor is trying to push it. So just trying to print a layer there. We will see what actually comes out. No, it is printing actually. So bed level test we are done. So it is printing. So the purge when it happens, it starts from that end till this end. We'll do a purging when we print the part. So purging will happen. We'll try to do that. So since we have done the bed leveling, we have to test whether the bed is leveled properly or not.
So first is level testing.
Yes. Yes. Sir. So it is printing, I think, on all the points where we have tested. We have done the adjustments. So if it is printing at all the places correctly, then definitely it is well adjusted. So we can see that some of the part is not printed because the fiber was already not ready up to the nozzle. That's why it is missed. So that is not a big issue. Are you able to follow that, sir?
So here sir, we cannot control fabric temperature.
No, we cannot control. It is not. That is why whenever we are printing some parts on FDM, we are making sure that the bed is heated, but here we don't have. That's why these people have given us the school glue also. So we have to glue this. So it is adjusting properly one by one. We can just see how actually there is no disturbance and it is printing properly. So it will be printing in all these three places where we have adjusted.
What is the cost of this printer?
This cost are around 17 lakhs. So that's why I call this as a white elephant. Yeah, because with that we can get 2 SL printers very easily. We can say we can even get 3 if you bargain.
One more disadvantage that I found in this is that you cannot export G code to make any alterations.
Everything is their proprietary, and they whatever they would do in house. They do not let us know what is happening inside. So our test print is successful actually.
Third party is prepared.
Okay, so this also fine, this also fine, this also fine. So it is printed perfectly well. So my printing is done, I'll click on done. So my printer is ready to print, and we'll see other options also. Meanwhile, I'll request one of our interns to help me in removing these parts. हिमांशु, can you please ये सभी पार्ट्स को इसको निकाल करके अब ध्यान से लेते हैं इसको वापस टेबल पे रखिएगा ना, तो गिरेगी. So meanwhile we'll see other things also. So materials. I hope we have time. We have 1 hour, na? We'll do it easily. And there is option called as load plastic, unload plastic, reset plastic meter, load fiber, unload fiber, reset fiber meter. So whenever you are using a new filament, you can come. So whenever you are using a new filament, so in case you are monitoring from somewhere else, your printer is here, you are monitoring from, you have gone for a conference and you want to print something, you are monitoring from there. You do not know how much filament is there. So just with the help of the meter, we can find out how much filament is there. If you have loaded with the meter. If you have loaded with the meter. So placing this is very easy. 3-point mount is there, just place it and leave it. It mounts easily and there is no requirement of any kind of adjustment once again. So we'll do one load plastic and unload plastic, and also we'll do for the fiber also. So since the plastic is already loaded, fiber, whenever I say plastic, to think in terms of composite as a matrix. In the whole laboratory, this is the minimum used machine. Because we don't have the independence in research, what is required is the independence, independence to configure our own materials. Here we can't do anything except for design. So what we are going to do is we'll unload the fiber, unload the plastic, then lower it back, and we'll skip for the fiber, and then we'll go ahead with some other parameters which we have here. The most interesting part here is seeing how the filament is getting deposited on the fibers, because that is what makes this printer as unique. But you see all the controls, everything is just similar to other FDM printers, except for this, the nozzle and fiber. It is telling. Press next to continue. Okay, you good name? Karthik, please. So this touch is not so good, so press once and wait for it. Okay, what is telling? Cut the filament from the inlet side of the extruder and remove the bowden tube from the outlet. So filament from the inlet side of the extruder. So this is our extruder. Okay, I'll just remove it. We had a cutter. This is a screw. I just unscrew it and I'll then I'll click on next. Wait a second, one more thing I'll do. It is expelling. So we can see it is expelling there. All the unused filament is being expelled. Yes. That's it. It will not expel more than that. So now it is telling pull the remaining filaments. So I can just open it from here. Or else from there. And remaining filaments, I'll just pull it out quickly. So my remaining filament has come out. Then what it says? Stop. It is still pushing. We'll do stop. Click on stop. Because this work is done. Remove the filament from the plastic bottle tube. So from the plastic bottle tube, I've already removed it. From the outlet of the extruder, there also I've removed it. And attach the feed tube to the inlet of the extruder. This feed tube is there. I'll attach to the inlet of the extruder. How many people can take 5 minutes? Yes. However, I tell you, this is the printer and this is the dry box where we keep the filaments. Dry box is basically good because normally all the filaments they are affected by the humidity and it becomes bitter and it doesn't print well. So we keep it in the dry box. So it says remove the filament from the plastic bottle tube. It is done and I have to mount this. I have done that also and then I'll click on next. So I have successfully removed the filament. That is what it says. Now I think so that is clicking in. Is light off? Is light off? So now it is saying load plastic. Okay. So I'll just guide him and he'll load the plastic. I have unloaded the plastic. Similarly, we have to do for the fiber also. Okay. So you go ahead and load the plastic. Click on load plastic. Yes. Great. Just you have to follow the instructions. Please read it about.
Please make sure your dry box is latched closed at the end of this utility.
I have lashed it.
White plastic is a leading cause of print failure,
Yes.
and the plastic will absorb significant moisture when exposed to air more than 15 minutes.
Okay. So now it is telling giving option quick load or meter load. Now I do not know how much filament is there, so only option I have is quick load, no meter load. If I know how much filament is already here, I can click on meter load and place it there. So as of now, we'll do quick load. We'll do it. Yes, yes. Now it is asking what type of plastic are you loading? It has the option onyx, nylon, precise PLA, then smooth TPU. So we had some materials. This is precise PLA. This is little bit softer compared to the other PLA materials available. And we have onyx material which we are currently printing here. So this is onyx similar to the carbon fiber infused PLA fibers. So we are not using any of them. We are using this onyx material. So we'll click on onyx just once. Touch it. Onyx. So now it is telling something. Clear the leftover filament from the extruder if necessary. When finished, press next. From the extruder, if there is a leftover filament, I have already removed it, then I'll click on next. Now it's telling put the plastic into the filament feed tube. Until the extruder is loaded, wait for the plastic to feed through the tube. When the plastic starts coming out of the nozzle, press stop. So still it is not coming, it is trying to push, it is not coming, it will come from here, it will try to come out of the nozzle. So the reason why it is not coming is it is not matching with the gear which is used for pushing the extruder. So I'll give a small push from here. Yeah, I just since I have removed this bottom tube, I place it back and then insert it. Sometimes what happens because this place and this fiber also come, it stuck here. And because of that, this filament gets stuck there and you have to remove all these parts. So I prefer some extrusion and then placing it back and then tightening. I have tried to get back. Okay, I'll click on, since the extrusion has not happened, I'll click on retry.
Repeat step हो गया ना?
Yes. So now the filament is coming all the way and it goes to the normal. For this you have to be a little bit ready and cautious that when it starts coming out, then you have to click on stop. So kind of tac sound will start coming. Yes, stop. So now our filament is coming from here. Our fiber is is loaded. So somebody would like to load the fiber also? You will do? Okay. So you have to unload the fiber. This part is done. Click on done. Unload the fiber and somebody else can load the fiber. Okay. So we are already done. We'll do again. Okay. Yeah, click on that menu button. Yes. Actually, the touch is not so responsive. Materials. Unload. Just we have to follow the instructions, whatever it says. Next one is use this video.
Press next to disable the fiber extruder so that fiber can be easily unloaded. Carefully rotate your currently loaded fiber spool to remove your extra fiber on it. When done, be sure you tap the end of fiber to the spool to keep it from unspooling.
Yes. So now it is saying I have to rotate it, start coming out. We have to be very careful. When it starts coming out, we have to make sure that we are holding this. Otherwise, that will just unfold and just like all the fibers we just showed, they all came off as a kind of spring. It comes off and so hold this and try to rotate it and get all the filaments out. Yeah, let it get it. It's time. Yes. Because it was still there.
Yeah.
So this is what precaution we have to do, otherwise this will just unspool and this will be okay, so this what is the next step? This is what is the next step? Carefully rotate your this is done. You have successfully unloaded. So you like to hold it back again, but you have to be very careful again. So this is not possible. So hold this with one hand, place this back there, and this is that is a magnet. It will help to actually mount So also yes, I want to load it. Then quick load. Yes, quick load. Yes.
एक बार जब दूसरी में से पार्किंग गायब हो गया है ना प्रिंटर का कैसे फिर रखने से कुछ
No, actually I was avoiding the double hits. That's why I didn't do it. So it is read it. So it is read it.
दो में से एक ही उसमें से आपको प्रेस करना
Then wait for fiber to heat to review. When fiber starts coming out of the nozzle, press cut.
Fibers are coming. So now both of the things are loaded. Click on done. loading as well as unloading of this fiber as well as the plastic has been done, and we'll see what other options do we have here. And I think so most of the work is almost complete. You click here, click on option storage. So previous prints whatever we had, it will show here. And you can see the logs. If there is an issue in the printing, all the logs you can take in the PC and you can just see them whatever thing happened, or if there is any failure you can see why it actually failed. Print job history we can go and see whatever parts we have printed will show here. So in case you are not connected to your PC, then directly you can print your already printed file. Then utilities, manual control, maintenance schedule, these are not of much interest. Test print we can do right now. Other things we'll see, print queue, if something is already printed, just like our normal printers, if it is already given in print queue, we can see here and we can give the print. Still, I think so now we don't have any kind of print queue. If it is not showing, we can click on refresh. It is refreshing. Still, there is no print queues. It will come only once we give the print from there. Then we'll go to settings, we'll see whatever is there. Network manager, we have to connect this with the Wi-Fi, or else LAN is also available. Update manager, anytime you have to update the firmware of this. Then in system information and all that. So we are almost done and our printer seems to be ready. So since the printer is ready, it must show there that the printer is ready, right? So we'll just have a look there, whether the printer is ready or not. Okay, everything is fine. Yes, we see here the green tick. One printer is ready. So we are all good for printing. So this is our part which we have just now done, and I can save it. Only option now I have is to print. Okay? Yes, please give the print. We'll see whether it prints, whether we have a good luck on that. It says something is happening. Again, this is actually the overview. You have to keep print one second. Yes. Print new or add to queue. If you don't want to print right away, you can click on add to queue and you can go there and see and add. The queue will be visible. You can click on the queue and you can start printing. If you want to print right away, click on print now. So whatever print is happening, you can monitor from everywhere, anywhere. So not only from this laboratory, if I have my laptop in my library, I can monitor from there also. So you can see. So both of them, that is showing that it is printing, and this is showing the dashboard. I can stop the print from here, and the same thing can be done from there also. So it is telling that 1 hour 47 minutes is left for printing. So only our focus is that we see how this part is printed. This carbon fiber is being laid off. After that we'll let it print, and then finally we'll check the dimensions in the same way. The most important thing is that whenever we are printing, since we have done the test prints, we know that it is going to print well, but still we have to see whether the first layer is printing properly or not. If the first layer is printing properly, we can say that yes, this printer as of now is reliable and you can go ahead with it. Still heating. I didn't get the question.
It's showing 294 degree and fiber temperature is still keeping on increasing.
Yes.
So are they reaching the same temperature?
No, they have that different temperature. I don't remember the temperature, but we can see how much temperature is actually required.
Honestly, carbon fiber not say with others, so you don't
Yeah.
get a different shade, which is the layer of light.
Actually, that will be shiny when we are we are placing this carbon fiber, that will become a little bit shiny.
So it goes in greener part, right?
Yes. So we can see it. It will be visible. We can see it. So it is running a purge line. So I think so this is one thing that you want to see, that purge is happening. Yesterday I had printed some parts. Actually, purging, what is purging is actually if some of the filament is stuck here, or if the filament is not reaching up to the nozzle and we start printing, it may start printing the air and the print may not come out properly. So extra material we just deposit on the bed to make sure that the purging is happening properly and the temperature is proper and deposition is good enough. So that's why it deposits some extra layer before printing. So that is called as purging. It is showing the running purge line, it seems. Here it shows running purge line. I don't know how you can blur. Yeah, it's showing something. It's okay. Okay, it is purge line is happening. So one of you can just skip the purge line, that doesn't matter. Yeah, you can click on the, it has stopped, the purging has stopped. So at the end, it prints something extra, whether we can say that's a wastage of material, but every layer it goes and calibrates. So sensor calibrates whether the printed part is at the same level as intended or not. So a kind of well will be printed at the corner and our main part will be printed here. So I have done a small mistake actually, that I have not placed this glue on it. I'll see whether the print is coming good. If it is not coming good, I'll have to put this glue on it. So as of now, how many layers have we put fibers? On the fourth layer. So only on the fourth layer we will be able to see the fibers. Hopefully we can see it by now. And it will show here layer 1 of 40. So layer 1 of 160 is actually printing. So when the fourth layer comes, we will have to just see whether it is printing or not. Top also it is, but that will take enough time. That will be a lunch time. So while printing, we have to make sure that we are not disturbing. I am telling that not disturbing and I am disturbing. Okay. So this is actually the purge line. Extra purge will be happening. Since after this purge, he has skipped the purge, so it will just come as a normal line and will purge it. Okay. So we can say this is a waste of material, but that is a safety precaution that our part comes out proper.
Is it the printing time which is mentioned 1 or 45 minutes?
Yes. It actually takes a lot of time for me. Because just like the FDM and also the accuracy is around 100 microns. So it takes a lot of time. The surface finish is very good actually. Here we cannot even increase the speed of the printing.
So you don't parallel with this weekend.
Nothing is-
Another one is being able to read.
Nothing. So whatever we are giving on that. So after every year it will go and print a well there, just to make sure that that is at the.
Yeah, all the, you got the other person.
So there too is printing.
So this I, before I say and
ಇಲ್ಲಾಗಿತ್ತು ಆಯ್ತು ಬರ ಅವ್ನ ಕೆಲಸ ಆಗಿರ್ಬೇಕು ಹೇಳ್ಕೊಟ್ಟ
It was 4 and 5. 4 and 5. deposit it, it will become flat and be shiny, kind of glass basically, and will deposit.
No, I did not record.
This is Onyx, the natural. Yeah, that is punching the. Yeah, that is just the value difference. It's called calibration of the height. So there is no carbon fiber. Yes, our carbon fiber was good because that small filament what you see here, so that comes around 7,000 rupees. So 1 kilometer you see here, that comes around 30,000 rupees. So that is not
possibility carbon fiber pattern both you printed full completed
Just
one piece
bottom part.
bottom part. No, what goes me man?
Camera.
Just tell him that in the name of Ritura, I will do पहले सिक्योरिटी से पता कर लो मिला के So this is layer 4. Maybe it will start depositing this fibers. Bottom also it was there. I'll check it.
Between for half and full.
Yes, 4th and the 5th layer was there, so it will come. Is it coming?
Yeah.
Sir, आपको there are 3 carbon fibers, sir. 3 layers of fiber.
4 to 5 is
So now the filament is getting deposited. So 2 layers, the filaments will be deposited. Thereafter we'll have a gap over on the these after 5 layers of fiber, this matrix, and then again the filament will be deposited.
So I think there's some stuff they want to see again that.
Yeah. Yes, it is 160 layers. I think so the height is 30 mm, so it takes 160 layers. This actually takes a longer time for printing compared to the other FDM printers.
1 hour.
They have removed actual posters, or posters.
Now I think there is a manual. So after that, which layer do we have? We have from the 9th layer up to 11th layer. So then only this fiber will be deposited. So this is actually how we are printing these carbon fibers. As I said, the disadvantage only is that it cannot be printed on the curved surface and also on the vertical surface. If you want to print on the vertical surface, you have to make sure that is aligned properly in the required angle.
a lot of time.
Tell me.
Yesterday we went with
You went with? Who is Janardhan? Janardhan Reddy. SW, you should start with SW. Then extend it. I'll write an email. So if you would like to extend it, I'll approve.
As a experiencing that pulling. Pulling is not happening, not the right part. And it's moving.
one semester plus half semester.
You extend it 2 semesters, no?
Yeah, sir, but testing part will have to be there.
You can do it naturally. When is the submission?
Fourth semester is going on.
But that is not so different.
Fourth.
4th semester it is starting in February. When it, until when it will go?
Still
So
till the
specific requirement of pulling is not required.
Okay. So which means half of the semester you can stay here. Then half of the semester you can do.
But in those
You can extend. Why only one? You can extend one. You are extending for the second semester or not project? Then you should extend it to your stay also. Not saying that you should not go. You go and then come. Ah. See, anyway, you are extending. Are you extending your project to second semester, 4th semester, right? It is basically 2 semester project. You extended 2 semesters. You only pay how long you stay. Like example, you stay till March. You basically work until March, or even if you are finished by February, you stay till February and then leave, and then do the test there. That is the one possibility. Second possibility, you go there, stay for a week, and then do a few tests, and then come back, and then again go. If I extend it to January, and then again you need to actually extend it.
Design it. Model. We have a rental. There will be a model. In case if they want to. Just involve
So you think you'll be able to finish by February?
We want to, sir. The speed is very slow on what we are working, so it may take time.
She's happy to stay. You are want to run now.
These 4 people will help you in modeling. In case there is ma'am will help you.
Of course, our interest is only.
In case
But
we
the
cannot
speed
do something,
at
just reach out.
my work is progressing is very slow.
Very slow. Why do you think very slow? You are not going.
Because I'm still at the initial phase and I'm just working on that. So I need to take time. I need to be going.
Yeah, you should work hard. Spend more time. Extend it. They're saying to you, extend it. You can leave by end of stay. Because why I'm saying you leave, then you have to come back. It is like a fresh. You have to give pay the registration fee, time payment, all the next time. And then without other, they will give that time. Right? So, our project has a lot of set. Maximum